Okay then, so now let's do something a bit more involved and set up a multi-species Mizer model. So I'm basically going to go through the setup, well, the outline of the setup of the North Sea model discussed in the Mizer vignette. So this is fairly advanced and quite involved, and so we're going to need a new tool to help us, and those are going to be R script files. So basically an R script file stores code in text, and it's easy to run different lines of that code through RStudio. So I'll show you an example. If we go to new file, R script, it makes an R script up here. So we could have a script that says, for example, first line will be x is 2, and then what's x plus 1. So if we put the cursor, click on a particular line and run, it just drops that command into the R console and runs it. And we can then do that for the next line. We can also highlight multiple lines and run them all at once. Okay, so we're going to want to set up a script file like that. Actually, I've already got one copied, so I'll just paste it in. So it looks a bit like this, okay? These are the different commands we're going to use to set up this North Sea model. The beauty of script files is that you can save them, edit them, and run them again, and so on. So basically, the hard part comes first, and that is telling R where to find the basic data underlying this North Sea model. So I'm running a bit of a different setup to the one you probably are, and so unfortunately it's a little bit different telling your computer where to find this data file. So I've actually commented this part out, but this is the command that you should run. I'll just drop it into the console so it's clear. So basically, we want to make a Mizer params object like we did before to store the basic settings for our simulation. But since it's a multi-species model, there's quite a lot of information to specify, and it would be quite lengthy to go through and describe all the different parameters of each of the different species in our model. So it turns out that they've already been written in a data file which is part of this R package, and if you run this command here, that will basically get you this data. It's stored as what's called in R a data frame. Okay, so basically in here, this is hopefully finding the directory where this file is stored. So basically our objective is to feed in this data here and get it into a data frame in R. So this system.file thing finds the directory where this file is stored, and this read.csv command reads this into R as a data frame. Now, so if you run this command, it'll work. For me, I want to run this command here. That's why I commented out the top line. So for me, I'll run this, and now I've got my params data. So let's have a look at that. If we just press enter, we see it's basically something like a table giving different parameters for our different species. So we have 12 different species here, and we have recorded their asymptotic size, maturity size, preferred predator-prey mass ratio, width of feeding kernel, maximum recruitment level, and von Bertalanffy parameters. Now, we also want to add in the so-called interaction matrix. So that's going to be a 12 by 12 matrix, and the IJ entry in that is going to tell us how much species I interacts with species J. So that's also data which is already stored as part of the R package, and we can just read it in. For you, you want to be running this command here without this hash at the beginning. The hash just comments out a particular line of an R script so that nothing happens when you try and execute that line, because as I said, I don't want to use this, but you do. So you should run this command to feed in the interaction matrix. I'm running this command. The reason why it's different for me, you don't need to worry about, but basically it's because this package, this particular version of R which I'm discussing, at the present time hasn't been released. Probably within 2 days, by the time you've seen this video, it will be, and you won't have to access it like what I am. So anyhow, for me, I specify the interaction matrix like this, and then we just need to do a bit of cleanup. So basically, if we have a look at this interaction matrix, it's stored as I believe it's stored as an array. Let's have a look. Or is it even stored as a data frame? But anyhow, we want to convert it into a matrix. So we do this as command here. So it's basically just changing the type in which R is storing this data. Nothing to really concern yourself with. It just changes how R labels it. So we use this as enter comma matrix thing to make sure that R is storing this as a matrix. And now we have the underlying data for our model and the interaction matrix, and we can use those to produce a Mizer params object. So I found this a little bit confusing at the beginning because there's various different commands, but the commands I've talked about so far in the previous videos, being the set community model, the set trait based model, those were making Mizer params objects, and this command does the same thing. The only difference here is that it's sort of doing things in a more general way. Basically, the underlying information, the sort of few numbers that you need to specify what's going on, are stored in this data frame called params data, the one that we just read in. And we also specify this interaction matrix. Given that information, Mizer produces this Mizer params object, which is a sort of filled out list of parameters where lots of different things that Mizer is going to need to know to run the thing are calculated and stored as slots. Okay, so it's analogous to set community model, for example. So there we are, we run that. Now let's have so notice I'm running the commands now through this R script. So I just tap this button, it just essentially drops the command into the console and runs it. So if I run this, so let's have a look now at this params object. It has various different slots as before. If you type an @ you get a nice list of the different slots, and one of them is called species params. So let's run that, and that shows us lots of information about these different species. This is stored as a data frame, and we can access different parts of it. So if we go params @ species params, and now to get different parts of this data frame, we use a hash. Sorry, we use a $sign. So let's say we want to have a look at the values of beta, the predator-prey mass ratio. So if we just type beta, when we see this kind of column of the different beta values for the different species, or we can actually look what the species are. And we can do these different things to get at these different pieces of information. So let's say we wanted to know the beta value of the third species, we could do so like this. Anyhow, the important thing is that we've made this params object here by running the code up to here, which is basically ready to run. So we just run this in the usual way using this kind of command here. So we make a sim object, and it's the result of doing project. And we specify the params object, the fishing effort, the runtime. This dt here is the size of time step that our numerical partial differential equation solver uses. And tsave here is how frequently the data is actually recorded. You see, you want to make dt small enough so that the PDE solver is accurate, but you won't want to save loads and loads of data every millisecond of runtime or something. I mean, you wouldn't want to store loads and loads of entries of data for really small time steps. So you should set tsave a bit larger. I'm saving every year. Okay, so let's run this thing, which is going to make this thing called sim, which is storing the results of a simulation. And now we can plot this. So we get this nice plot showing this interesting simulation of what's going on in the North Sea. So if we zoom out, there we have it.